All right, we only have 2 more chapters to go. This one you're going to have to do a lot of integrals.
Wait.
Is it line and surface?
Line and surface integrals.
Alright. Let's go get it.
Talking about this? Yeah, if you want to sign up for the AMC 12B, because you guys are automatically signed up for the A, but for the B it's optional, so you gotta put your name there by today.
Who's the third one?
Who's the third one? Matsuzaki?
Oh.
Okay, so first we're gonna learn about line integrals. Now, you guys already learned how to compute force, right?
Yeah.
Not force, but work. When you compute work, when you first did it in physics, how do you compute work? Force times distance. But that's only if the force is working in the direction of the distance, right?
Yes.
And it has to be a constant force, right?
Yes.
But what happens if the force is variable?
Alright.
You guys did this in BC, right, last year?
Yes.
Then you do an integral, right? But then what happens if the force is variable and the path is also variable? It's not a straight line. Then you have to do a line integral. So line integrals are used to compute work. So basically, to compute work, this is what you got. Here's the force function, f of r of t dot r prime of t. And you do an integral from t1 to t2 dt. So this is called a line integral. Okay, so you got to do a dot product. You need the force vector, and then you need the position vector. But of course, once you get the position vector, then r prime is the velocity vector. Yeah?
Yes.
Okay. So let's do it. I'm going to do 2 examples. I'm going to make one of them just like the homework. In fact, we're going to do one of them because D is kind of complicated. It comes out. So we're going to do D in class. But before we do D, let's do an easy one. So let's say the force vector is, why don't we just use the same one they have there, y, x, except let's choose a different path then. The unit circle. Now on the homework you have to go clockwise, but let's go, is it transversed or traversed? Traversed. Traversed clockwise from the point 1, 0 to 0, 1. Traveled. Okay, so here's the unit circle, right? So you're going to go from here to here, counterclockwise, applying this force. What is the work done? How do you compute work? Well, you just compute this line integral. Okay, let's see if we can even set up the integral. Okay, so what is f of r of t, first of all? F of r of t is equal to, well, first of all, what you got to do is you got to write the equation of this in parametric form. But come on, the unit circle. And you want it to start here and go counterclockwise to there. Cosine t, sine t, right? Did you guys forget that this is the unit circle? It looks like it. Okay, here, let's go back to pre-calculus. Square the equations. X squared equals cosine squared t. Y squared equals sine squared t. Add x squared plus y squared equal 1. See, that's the unit circle. And then, so, yes, it's going to travel on this, but then we're going to do it from t equals, see, some of the problems, they just tell you everything, but of course on the test, I'm not going to tell you, right? You got to figure it out. So, we want to go this point to this point. So what is the value of t at that point?
Yeah.
0 to t equal, what is the value of t up here? Pi over 2. So this is your t1 and your t2. So that means your position vector is simply cosine t sine t. Right, remember the position vector is simply parametric equations. You just put the x here and put the y there, and if there's a z, you put it there. But this one is only two-dimensional, so it's easy. So now, what is f of r of t? You have to take the position vector and plug it into the force vector. So y, which is, what is y? Sine t. And then what is x? Cosine t. Okay, so that's f of r of t. Now we got to compute r prime of t. But that's simple enough. If this is r, what is r prime? Negative sine t, comma. I forgot that our derivatives. Wait, this is multivariable, right? Okay, now you got a dot product of two. See, dot product. So how do you dot product? This times this plus this times this. So what is this times this? Negative sine squared t plus this times this, cosine squared t. And we're going to integrate that with respect to t from t1 to t2. 0 to pi over 2.
Use my body.
Okay, use some body. Cosine 2t. So integral 0 to pi over 2 cosine 2t dt. Antiderivative? 1/2 sine 2t from 0 to pi over 2. Factor out the constant. So you get 1/2. Plug in the top number. Sine of pi. 0. Plug in the bottom number. 0. All that work for 0? I guess that's because the force field is something that cancels out the work of the thing. Oh, I didn't want it to come out to 0, but some of the problems do come out to 0. Are you guys good at physics?
Yeah.
No.
No, I'm trying to think of a system, because I'm not really good at physics at all. I don't even barely know
Yeah,
physics.
the force
In fact, a lot of the stuff we're going to learn in this chapter is physics applications. So if you guys are in AP Physics C, you should be dominating this then, right? Unless you don't know how to, hey, stop it. Unless you don't know how to compute integrals. What would make the work come out to 0?
Is it if it's tangent? I mean, yeah. It's like uncurved.
It just depends on what this is too, right? Of course. Don't worry, I won't make it come out to 0 on the test. Unless it does. Okay, so now let's do a more complicated problem, which is D. Now D, on the video one that I did, on the written solutions, I only did the first path, because there's 3 paths. Because there are like 3 sharp points, it's a triangle, so you have to do 3 integrals. So I only did 1. But we'll just use the class to do them all. And let's see if we can get the answer. See, this is why you gotta know parametric equations, otherwise no can set up the integral. Okay, this one might take the whole board, because we gotta keep it on this side over here. Okay, so we are doing problem 1D. So I'm gonna, once we set up the integrals, I'm gonna assign you guys to do one integral, and then we'll put them together and we'll see if we can get the answer. Okay, so the force vector is cosine x minus y sine, oh, this is 3-dimensional. No, I just can't see. Minus y sine x, comma, cosine x. And then over the triangle with vertices 0, 2, 2, 3, and 1, 4. Oh gosh. 1, 4. Like that. Traversed, which way? Counterclockwise. So which point do you want to start at? This one. Okay, so we're going to start here, and then we're going to go from here to here. So that's going to be one integral. And then you're going to do another integral that goes from here to here. And then you need to do another integral from there to there. Now, does that, since you're ending up at the same point you started with, does that mean the work is going to be 0? Well, it could be 0, but it's not going to be, I don't think, because of this force field function, right? Okay, so here we go. So what we need to do is we need to write the position vector for this. So why don't we call this path 1, path 2, path 3. So now we do path 1. What's the parametric representation of the line that goes from here to here? You guys remember how to do it? Or is that gone from the memory? Okay, so what you're going to do is make a vector that points in the direction of the line, right? From here to here. How do you write that vector? Head minus tail. Head minus tail. And then you take the initial point, so you go 0 plus 2t, and then 2 plus 1t. Remember that? Because at 0, like if you plug in 0 for t, you get this point, right? If you plug in 1 for t, you get that point. So t equals 0 to t equal 1. So it's going to be t, that's how this thing works. T equals 0 to t equal 1. That's going to be your limits of integration. And then so your position vector is going to be 0 plus 2t, 2 plus t. See, parametric equations, x, y. X component, y component. Okay, here we go. So now we need f of r of t. Okay, so if I take the position vector and plug it into the force field, what do we get? Cosine x, so cosine 2t, that's x, minus y, 2 plus t, times sine x, so sine 2t. Did I do that correctly?
Yeah.
Of course, I'm the teacher. Although sometimes it just doesn't come out either. R prime of t. Oh wait, we only did that component. We still got to do this component, cosine x, so cosine 2t. Okay, now what about r prime t? This is r. What is r prime? 2, comma 1. Okay. Now we got a dot product then. So this times 2. You want to distribute the 2 already, or just put 2 times that?
Distribute.
Okay, so 2 cosine 2t minus 4 plus 2t sine 2t plus 1 times this plus cosine 2t. Now you have to integrate that from 0 to 1. And that will give you the work done from here to here with that force field there. So that's just path 1, okay? Now we do path 2. Okay, now after a while, you don't have to go x equal, you can just put it into the position vector already, right?
Yeah.
Okay, so again, we're going to go from t equals 0 to t equal 1. Okay, so the position vector will be, okay, so how do you write the parametric form of the line that goes from here to here?
Negative.
First you got to write the vector, right? So head minus tail. Head minus tail. So what is it going to be? 2 minus t, comma, 3 plus t. Okay, now we got to do all of this stuff again. So f of, we got to make room because we got to squeeze it all in one word. F of r of t is equal to, okay, here's the force. Now here's the position vector. Plug it in there. So you get cosine 2 minus t minus y, 3 plus t times sine 2 minus t. How are we going to fit this in?
That's just how it works.
Comma cosine x, cosine
You're saying-
2 minus t.
so we make it-
And then what is r prime? Well, if this is r, what is r prime? Negative 1, 1. And then we're gonna take the dot product. So dot product will be this times -1. So negative cosine 2 minus t plus 3 plus t sine 2 minus t plus 1 times this cosine 2 minus t. And we're going to integrate that with respect to t from 0 to 1. That will give us the work done from here to here. Now we just got to do one more path. What about from here to here? Path 3. Let's squeeze it in. So it's going to go again from 0 to 1. So the position vector is, how do you make a vector that goes from here to here? Head minus tail. Head minus tail. Did I do that correctly? Okay, so what do I put in for the position vector? 1 minus t, 4 minus 2t, correct? Okay, here we go. So f of r of t is equal to, so take this and plug it into the force vector there. Cosine x, cosine 1 minus t minus 4 minus 2t. You guys gotta check if I'm doing anything wrong. 1 minus t, comma, cosine x, so cosine 1 minus t. And then we're gonna dot that with r prime of t, which is, okay, if this is r, what is r prime? -1, -2. Is that correct? Okay, so dot product of them. Negative cosine 1 minus t plus 4 minus 2t sine 1 minus t minus 2 times this, so minus 2 cosine 1 minus t. And then we're going to integrate that with respect to t from 0 to 1. That integral will give me the work to go from here to here. So we compute all three integrals, and then we add them up, and then hopefully we get the answer on the bottom. Okay, Team D, you do this integral. Hong and Lerner, you do this integral. Park and Park will do this integral.
So is it always from 0 to 1? Like for any?
Well, when we write the equation of a line, it's just easier to go from 0 here and 1 there, right? That's the way. Isn't that the way we did it? Remember the review in the beginning? You don't have to make it 0 to 1, but it's easier if it is here. Okay, how do you write the equation of the line? Okay, pick any 2 points. 2, 3, 7, 5. What's the vector that points over here?
Comma 2.
Okay, 5, 2. So if you use the initial point, then x equals 2 plus 5t, y equals 3 plus 2t. So what happens when you plug in 0? Don't you get this point? Plug in 0 for t. You get that point, right? What happens when you plug in 1 for t? You get that point.
Yeah.
Yeah?
Oh.
So if you do it like that, then it's always going to be 0 to 1. But you don't have to do it. You can pick something exotic or even erotic. I don't know how you do that, but you could. Okay, so wait, Josh Park got a head start on me.
Yeah.
Okay, I'm gonna do this out of the screen, so you guys are not gonna be able to see. We'll put all the results here and see if they come out to the answer. Okay, antiderivative.
Oh my god.
This is not that easy. Wait a minute. Cosine 1 minus t. So this is minus that.
How does this do One.
Hmm?
2. Huh? Are you supposed to do the tabular?
Yep, you're gonna have to do tabular, unless you wanna do regular integration by parts.
No.
Yeah. That's so good, I'm good.
Well, you're working in pairs, so you double check each other. You don't just walk around pretending to do stuff, Song.
No, I did it.
You got it already?
Yeah.
You did the tabular?
Yeah. Ours was easy. I think.
Well, what do you do after that? I forgot.
Tic-tac-toe.
Yeah.
This times positive 1, this times negative 1.
And you add them?
Yeah. You guys are BC. How can we forget tabular? Oh, we could have added on. These cancel out. Shit.
I don't know how to do that. I was thinking.
Cancel out. We don't have to do that. It's like wasting time over there. Sine 1 plus 4 cosine 1. So 2 cosine 1 minus sine 1 minus 4 cosine 1. So I get negative 2 cosine 1 minus sine 1. Is that what you got, Park? This is what I get. Your answer came out something like that, with cosine 1s and things.
Oh, I didn't plug in T. Uh-oh. It's from 0 to 1, right?
What is cosine of?
Just leave your answer with cosine 1s or whatever.
What's cosine of 1?
Yeah.
Oh, you leave it like, oh.
Okay, you want me to give you an approximation? Okay, 1 radian is 57.3 degrees. Cosine of that
Wait.
will be a little bit bigger than, but cosine of 60 degrees is 1/2, so 0.5 will be a little bit bigger than,
Mr. Park?
wait, I'm concentrating. 0.53.
I calculated the whole thing wrong.
Can this be simplified? No, right?
T equals 1 to 0. Yeah.
Oh wait, it's okay.
I guess so. Okay, when you guys have verified your both guys verify, I'm gonna write it on the board. Okay, path 1, what did you guys get?
Sine 2
Say that's the
plus
equation.
3 cosine 2 minus 2.
Yeah, we never learned tabulate.
We did. You were at the soccer trip.
How can you not learn tabular when it's in the
No,
book?
I was on a soccer trip. I never learned how to do tabulate. I still don't know how to do it.
Okay, but we didn't, what about doing the integral review?
Sine 1.
I don't know. I don't know.
Okay, for those of you on video watching, so you're telling me that if I give you this integral, e to x cubed, e to the negative 2x dx, you're just gonna do regular integration by parts 3 times then?
No.
No.
Oh, in fact, what if, let's make it fit, you can do it 5 times? No, that's why you have tabular, it's a
How do you do that without tabular?
integration by parts 5 times.
So you mean
uv minus the integral of b du, you're gonna do it 5 times. Okay, who's responsible for 2? You guys, okay, what did you get? You guys verified your answer?
Yeah.
Okay, what is it?
4 cosine 1 plus sine 1 minus 3 cosine 2 minus sine 2.
Minus sine 2. Park, did you verify this one? Okay, so path 3, hey, okay. Okay, but you gotta realize, see, we're working as a team now. We're like NASA. If ours doesn't come out to the answer on the bottom, then everybody gotta double check. So simplifying this whole thing, oh, can't we cancel this and this? This and this,
This and this.
this and this. So what's left?
0.
No. 4 cosine 1 minus 2 cosine 1. Come on, you can add those up. Isn't that just 2 cosine 1 minus 2?
Wait, the answer is 0.
Who said the answer is 0?
The answer is 0.
Okay, so we did something wrong. Really, the answer is 0?
Yeah.
Wow. Don't worry, I'm not going to make it 0 on the test.
Oh, no, Mr. Park, that's wrong.
So we both did it wrong.
It should be 0 plus 2 times cosine 0, because it's cosine of 1 minus 1.
Oh, because we're plugging in 1.
Yeah,
So this is just plus 2 then.
yeah.
Oh.
Put 2 minus.
So this is 2. So we can't add anything together then. So this is 2 minus, let's just put it here. 2 minus sine 1 minus 4 cosine 1.
And take sine 1 out.
Okay, sine 1s cancel.
There you
Oh.
go. Yeah, oh.
Oh. Yeah.
0!
No.
Wait, if it goes back to its original spot, isn't it always 0?
Really?
Like for like,
I don't think so.
I mean like when you do like electricity, like even like the volt.
Yeah, but then see the force field, what if this force was something else? No, there's a reason why it comes out to 0, and we're gonna learn that on the second worksheet. That's because there's something special about this force. I'm not gonna tell you till tomorrow. If you wanna read it, you can just flip up and read the top of the thing. Well, since everybody's interested, why don't we do it then? No, just scroll down to the second worksheet. You have the first worksheet, there. Is that true? Work done is equal to the change in kinetic energy?
Yeah.
Yes.
Okay.
I remember stuff. I forgot this.
So look at the last sentence. The last sentence, if you don't know physics like me. Thus, if the force field is a gradient field, then the work done on a closed path is automatically 0. But that means this has to be a gradient field. This has to be the gradient of something.
I didn't know.
Remember when there was a problem on a test that said this is a gradient of what function? And remember a lot of you forgot to put the plus C?
Me.
Did you go minus 1?
How is something?
Well, you check. So look at this.
gradient?
Is this a gradient of something?
I didn't know.
Yeah.
Like, can I take the derivative of some vector and to get this?
Oh, yeah.
Wait, what is not un? Yeah, what is?
Yeah.
Huh?
And what cannot be?
Like the first one we did? What was the first one we did?
Y, X.
The force was y, x.
Yeah.
Okay, is that a gradient of something?
Oh, because the.
What is that a gradient of then?
Huh?
Cannot, yeah?
Oh.
So this one, no can.
Why?
Okay, what is that a gradient of then?
Y, X, wait, I don't know.
No. There is, no, you cannot.
And what's the derivative?
No, not the derivative of
I mean,
this.
the
This
X.
is a gradient of what?
Oh, it's
So
just,
that's like
Here,
the
listen,
basic
Mariana.
formula?
This is tomorrow's lesson.
it's just sine x minus y of cosine. Or plus y of cosine x, right?
What am I, no, just f equals what?
Isn't that the gradient of Y?
Sine x?
Yeah, that's what I said. Yeah.
Say that again?
Sine x plus y cosine x.
Okay, try. If you take the partial with respect to x, do you get that?
Yeah.
Yeah. If you take the partial with respect to y, do you get that?
Yes.
Yep. So there you go.
Isn't that one gradient equal to the other one?
This one? Okay, what is this a gradient of then?
Y, X.
Really?
Oh, we did.
Oh, it is.
We got 0.
Oh, shoot.
Yeah, but we still got 0, right?
Yeah,
we got 0.
Oh my god. But we didn't
Yeah, but it wasn't a closed path, was it?
Well, no, I think it's because it's like symmetrical about Y equals X. That's why I just canceled out.
Oh, that means, oh, shoot. That means when I did it on the video, I did it the long way. Because I couldn't think of this. Stupid. Well, whatever.
You're very
Okay,
smart.
we are done. So the key is you gotta be very careful and set up the integral correctly, because otherwise you're gonna be doing a lot of work and it's not gonna come out. Okay, so you guys will finish correction.